say that JaamSim at its present stage of development, I think, is superior to the commercial alternatives. I believe that JaamSim is easier to learn, has a better user interface, it's way faster than to execute, it has a more powerful expression system, it's scalable to much larger models. This is back to JaamSim's origin with Asenco. We built huge models at Asenco that I don't think would be possible to be built with many of the other software packages. And it allows us to do much better quality control and maintenance of the models using version control software like Git, which any of my team members will tell you was absolutely essential to producing these huge projects. And lastly, it's free and open source. So what's not to like? The JaamSim is also, I think, better than the other free open source alternatives. It's the only one that has 3D graphics and drag and drop model building. The other projects, the other free open source software, essentially are just code libraries, and that's fine, and you can do lots with those, but you've got a huge amount of work ahead of you to build a non-trivial model in these packages. And on top of that, you've got the problems of writing code for input and output routines, user interface, graphics, debugging tools and things. So you've got just an enormous amount of coding to do. SimPy is probably the most successful of the free open source software libraries, but it has much going for it. It has a huge user base, but it's a very slow piece of software. It's even slower than the other commercial packages. Too slow, I think, for industry, large, the kind of large models that we typically build. It always seems like going back to the distant past of when we built models by coding them in a programming language rather than assembling models through a user interface. So over the years, JaamSim has been increasing its number of downloads per year. We've now had a total of over 100,000 downloads since 2016, when we formed JaamSim Inc. And it's stabilizing at around 15,000 downloads per year. A huge amount of effort went into the creation of JaamSim, and it may not be obvious to people using the software. It's got nearly 100,000 lines of Java code. These are executable lines, including comments and excluding comments and white space. It was built over nearly 9,000 commits. A commit is a software development increment that you use as part of Git and version control software. It's a measure of just how many changes you've made to the software as you build it incrementally. So approaching 10,000 commits, which is again a huge number, and this doesn't include all the commits that were made when we were part of Asenco and developing the software from which JaamSim was derived from, and I'll tell you more about that later. The estimated effort that's gone into JaamSim is 30 person years, which again is a huge number. This is not something you can build as, if you sat down and say, oh, I want to build a simulation package and I'll start coding, 30 person years is not something you can do on your own or even with a small team in a reasonable length of time. As it's a representative of the development of JaamSim over the last 13 years since it was made open source, and about a decade before that while it was being developed at Asenco. The little graph below you shows the number of commits per month that has been made in the software since 2011 when it went open source, and you can see that the development of the software has been pretty steady over the years. So it is far from being legacy software, which is just carrying on year to year. It's still very much a live developing piece of software. So what's next for JaamSim? At this point, I think that the open source JaamSim is essentially feature complete. Pretty much everything has pretty much everything that it needs. That doesn't mean that there's not going to be improvements and refinements to things, new objects that possibly that come up from applications where somebody says, "Oh, that would be really useful if we had an object that did this specific thing," and I could see that this is something that has general applicability. Those sort of things will go into it, but all the big things in JaamSim are in place at this point. Some of the things that we've talked about for JaamSim is support for other languages. We've got some users in French-speaking countries who would like to have the user interface revised, so at least the keyword descriptions and tooltip pop-ups are in their language, and that's something that we think we can do in JaamSim. We'd also like to make it easier for people to add their own libraries of objects. It's actually remarkably easy to do this, and it's a very powerful tool in JaamSim. So if you have a specialized application and you would like to create objects to make those models easier to create for those applications, it's quite possible to do that in JaamSim. And you don't have to get into all the complexities of the user interface and expression system and what have you. All the tools to build those libraries are present in JaamSim. Something that clearly needs some work is some improved manuals. The present user manuals is several years out of date, and I've got a rewrite well underway of that to bring it up to date. We also lack, I think, a good set of instructional videos on YouTube that people can use to learn how to use different features. And I think that JaamSim hasn't really been promoted. It's always difficult to come up with a budget for promoting something that's that you're giving away free. But that's the job of JaamSim Pro to finance the development and promotion of JaamSim. And lastly, that there'll be lots of work going on for JaamSim Pro as new libraries are developed for that software. So what are our challenges for JaamSim and the adoption of JaamSim by a larger community? We've had 100,000 downloads, and we've got quite a nice user base. There are more than 100 people who have signed up for this conference, for example. But the market share for JaamSim is still minute compared to other packages like Arena, Simio, AnyLogic. And the challenge here is that the commercial packages, because they're expensive, have lots of money to pay for booths at conferences and books and all sorts of things that make to put that software in front of people and create a positive impression for it. JaamSim users generally have to discover the software on their own by searching the internet and taking a chance to see whether they like it or not. The challenge for a newcomer like JaamSim is that the users of other software, the people who are using Arena or Simio, they're locked into that software. They've got experience with it. They've had training with it, and they build models in it. So it's difficult for them to switch to something new. The something new there has to be a very strong reason for them to switch. Like they want to build a model which can't be done in their present software. And the same sort of thing happens for university instructors who are teaching courses on simulation. A lot of them are still using Arena just because they have all the course materials for teaching simulation in Arena, and they're not looking to increase their workload. I guess, and the last thing is, admittedly, the commercial software, Arena, Simio, AnyLogic, etc., do have lots of features that make them look very attractive. Now, there's some question whether typical users need those features and how useful those features are. But nevertheless, it's they benefited from many years of development, and that is an attraction for them. So probably the biggest challenge for JaamSim is effort required to promote JaamSim. And I think because of its strengths, I think the JaamSim should reach a market share of somewhere around 30%. So it's roughly a third or somewhere between a quarter and a third of the simulation of the people doing simulation using JaamSim. It's never going to take over completely, of course. So that's my snapshot of where JaamSim is now. I'd like to tell you a little bit about where JaamSim came from, because it does have, I think, a very interesting story that sort of goes right back to early days of simulation and my team at Asenco, just it is a saga. And it really starts back in 1981 when I was first introduced to discrete event simulation. And these are the days when simulation was done on mainframe computers, and you generally had punch cards that you filled out coding sheets, and punch cards were made up, and then you submitted the runs on a mainframe computer. In my case, it was usually located in Toronto, 3,000 miles away. And you got your runs the next morning, and usually with errors. And those runs could be very expensive. On a big model, they would be hundreds of dollars, $1981, which are worth many times more than $2,025. It wasn't until 1984, late 1984, when the first personal computer became available that was powerful enough to be able to execute discrete event simulation models. And I got a very early version of that computer in early '85, and was building an enormous model in SLAM software, discrete event software, but most of it was coded in Fortran. And this program was thousands of lines of Fortran code, extremely difficult to debug, no graphics, no user interface, no drag and drop. It was a huge undertaking. And I'd like to tell you, the kind of models that we're building, the application I was working in was bulk terminals. And so in this case, it was a terminal for that exported grain. And this was an immensely complicated model to do in this sort of software. The terminal I was trying to model had 280, I think, different bins of different sizes for storing grain. They were handling 50 different types of grain. They had multiple berths, complicated conveying systems, varying flow rates from the different bins. All this was just a huge amount of data. And when I first looked at this, I thought this was not possible to do it in the existing software, because the existing software was intended you would have to code logic for each of those bins, each of those conveyors, each of those berths, at all their characteristics one at a time. So didn't really see how I was going to do that for hundreds of different objects. But what I ended up doing was building an input file which provided all this data, and then the Fortran code would create the objects to do this and to connect them up properly in the simulation, and that made it possible to do it. But it was, quite frankly, it was still pushing the envelope. It was computers in those days had 256K of RAM available, which is nothing today. And we're extremely slow compared to what we have today. And these models took hours to run, and were hard to get even to a state where you're to a steady state where you're getting reliable statistics. But we could do enough that it was useful. So anyway, after personal computers became available and were able to do much more, that really revolutionized the way that simulation models could be built and what was possible, what was practical. In the 1990s, we started using a package called Audition, which had been developed by a company in Vancouver, and then eventually was taken over by the National Research Council of Canada. And this was quite a sophisticated programming language for simulation. It was based on the IBM Smalltalk language and had a 2D graphics package. And just to remind you, in those days, 2D graphics was on 640 by 480 pixel monitors, which is very low resolution by today's standards, and you really struggle to get any kind of meaningful graphics on those few pixels. So for the next number of years, we continued building models of ports and terminals. Wait, I'll say we, really me, and finally in 1994, we got a project large enough that I needed a team to build this model, and this is a model of LNG shipping from Alaska to Asia, with an icebreaking, and this is a proposed project in icebreaking LNG carriers, and it was being done for a consortium of Exxon Mobil, Conoco, British Petroleum, and oh gosh, Arco, I think it was. Anyway, so three major oil companies. And at that point, I hired two people, John Molendijk and Stephen Wong. Stephen is in the conference today, I noticed, which is good to see. He's one of the people who was key to the development of JaamSim. And so at that point, we had a team. And then over the next 8 years, we continued to build models of these types of applications and build software packages in Audition to do that. So we had software that could, general purpose software that we developed that would model these different types of terminals. So we had one package called Marine Transportation Model for doing shipping problems similar to this one from Alaska that I mentioned. There's a bulk terminal model, which was for terminals handling things like grain or coal or iron ore. And we also did a lot of modeling for the British Columbia ferry system. In 2002, Audition had reached its end of life. It was not compatible with the latest version of Windows, and it was time to, we had to do something. And here we had three substantial packages written in Audition, and we're running. So what are we going to do? We need to write new code, and the thought of having to convert all these packages and rewrite them into a new programming language was pretty unappealing. At that point, we hired Harvey Harrison, who at that time I think was a second-year co-op student in engineering science at University of British Columbia, and we gave him the task of writing writing a discrete event engine in a programming language. We chose Java over C++ because we thought Java was simpler and easier to work with, which it is. And he went away, not knowing how difficult this was, and wrote a really quite good discrete event engine in Java, and also then subsequently wrote a compiler that took Audition code and converted it to Java, and he was able to convert the code very nearly 100% to Java. The only thing he couldn't convert was the 2D graphics, which were unique to the Audition programming language. So this was a real triumph for Harvey. He then went back to university and carried on, and we took that engine and converted our marine transportation model and bulk terminal model to Java, and then Stephen primarily merged it. Stephen Wong merged it together. We created something called TLS, Transportation Logistics Simulator. More people brought in, Jeff Savinkoff, Ali Morandi, and this really became an increasingly powerful package. Over the next 5 years, our group started to grow very rapidly. we were doing projects all over the world. We were licensing the software to all the oil majors, and really going from strength to strength. In 2008, the company we were working for, Sandwell Engineering, was bought by Senco Engineering, an Australian company, and that brought some changes to the way we work, mostly positive at that time. And finally, in 2009, I was able to rehire Harvey and bring him as our lead programmer. And at this point, and over the next few years, we grew to about 15 people, and we were really doing a huge number of projects around the world. We were I think it's fair to say that we were kind of dominating projects in the oil and gas industry. We were doing all the LNG projects that had been developed at that time, and we're often doing big joint industry projects in the oil industry for where several of the participants in the joint industry project, particularly ExxonMobil and ConocoPhillips, were building their own models in TLS, but we were brought in to do an overall modeling because we could be independent and not and so people can have confidence that our results were not being spun by one of the joint industry project partners. We also started to license TLS to the mining industry, and I want to show you one of the models we made. You can see all the a lot of the models we made are available on a Senco's simulation YouTube channel, and we always put a lot of effort into making high quality videos because these are incredibly useful for attracting new business. If I went to companies interested in simulation and showed them some of these videos of our previous projects, and all our long list of similar projects we had done for other major clients, it pretty well guaranteed that we would get the project. So this particular model is one that we built for the coal mining industry in Queensland, Australia, and this has many mines, all moving coal by rail to 3 different export terminals, and it's just an immensely complicated system. And just I'll mention that this is metallurgical coal primarily. This is coal made that we use for making steel. So it's a good kind of coal, not the thermal coal. So let me just show you this model. It has a voiceover. You'll hear the voice of Matt von Schilling, who's in the conference I'm pleased to see this morning. And let's just play this.
The Goonyella supply chain in Queensland, Australia is one of the largest and most complex mine-to-port supply chains in the world. In this system, thermal and metallurgical coal from 31 mines in the Bowen Basin is transported by train to 3 marine terminals. To help inform decision-making for the Goonyella supply chain, Ausenco developed a simulation model on behalf of DBCT management using our Transportation Logistics Simulator, or TLS. This video showcases the simulation model, represented schematically, and demonstrates the breadth of features that were captured in the model. The Goonyella rail network and parts of the Newlands rail network connect the mines to the marine terminals. Trains transport coal along the rail networks, and their movements in the model are governed by detailed logic to ensure realistic interactions between trains. To handle the 54 unique grades of coal produced by the mines, trains bring coal to the terminals on a just-in-time or cargo assembly basis. The trains deliver coal to 3 marine terminals: Dalrymple Bay Coal Terminal, or DBCT, Hay Point Services Coal Terminal, and Abbott Point Coal Terminal. Of these 3 terminals, DBCT is modeled in the most detail as it was the focus of the study. At DBCT, coal is received at 3 inloading systems and either stacked to one of 8 stockpile rows that make up the main and remnant yards, or direct loaded to a ship. The model stockyard is managed by logic that ensures the efficient use of the yards and the yard machines, which reflects real-life operations. The numerous pieces of equipment at DBCT, dumpers, conveyors, stackers, reclaimers, surge bins, and ship loaders, were all modeled with rates, movement times, and planned and unplanned maintenance. The 4 berths at DBCT handle vessel sizes up to very large capes. Each vessel undergoes a series of activities at berth and has a modeled loading plan that explicitly captures the hatch pours, hatch changes, draft surveys, and trimming. Vessel movements to and from the berth are subject to tidal restrictions and channel navigation rules. To capture all of the details of the Goonyella supply chain and DBCT, the model included over 1,400 unique objects. Despite this complexity, the model was developed in only 4 months, with frequent feedback from DBCT management, thanks to the advanced features present in Ausenco's TLS software.
So I hope that gives you a good idea of the kind of models we created. A lot of the features in those models are the ones that ended up in JaamSim. But I will point out that those models were built without the expression system in JaamSim. A lot of the user interface features we had, and it was quite a bit more challenging to create those models than it would be now. So that it was impressive that we could do this. Now, we were doing very well with TLS. We were able to do projects to a higher level of quality and detail, and do them faster and at a lower cost than our competitors. And our licensing of TLS to the oil majors, Exxon, ConocoPhillips, etc., was, gave us a great client base, but also gave us huge credibility in the oil and gas industry. So we were able to do, for some of the smaller oil and gas companies, we were able to do work for them because it was clear that we were industry leaders in that field. The mining industry, where we also did a lot of work, it was much more difficult. We had more competition there, and there was the phrase we heard all the time was that the clients wanted to use industry standard software, which usually meant Arena at that time. And this was a real problem for us. We certainly were going to do projects in Arena because we would have no advantage over our competitors, and it would have taken us many times longer to do this if we could do it all in Arena. But the clients didn't know that, and they saw all the promotional material for Arena and saw how many people were using, and just assumed that it must be better. So we had a real credibility problem with TLS, and we were thinking, how can we address this? And it was also difficult that TLS was our own software being developed by a consultant, and generally, consultant software doesn't have a long life. Consultants usually aren't willing to put the effort into developing and maintaining software. So there was a certain amount of justification in clients being a bit suspicious of TLS. So what should we do about that? And the idea we had was that, well, if TLS had been merely an extension of an established simulation package, then it would be much more credible because we weren't building the whole thing ourselves. So people could look at the standard simulation software and know that was reliable, and then it would be reasonable to think that we could build extensions to that that would for our particular application. So our idea was, well, let's take TLS and pull out the bits that are generic: the discrete event engine, the user interface, the input and output tools, all those sorts of things. Make those open source, and if we make it free open source, it'll eventually get a good user base, and It'll help to undermine the dominance of Arena at the time, and our software will end up being much more credible, and we'll be able to license it much more easily. So, so that was a great idea, and I spent the next 2 years convincing Ausenco management that this was a significant problem, and this was the right solution to it. Uh, it was a big challenge to convince management, and I've got long essays I've written on the topic of why we want to do this, what's the business case for doing it, and so on. And eventually, I think that they relented and let us do it, probably just to make me go away. And they thought that, well, it probably couldn't do any harm. He's probably going to fall on his face, but it won't cost us anything. So in 2011, end of 2011, we finally got permission to make JaamSim open source, and we released it on GitHub. At that point, there wasn't much you could do with it because we didn't have we had things like queues and entities and things, but we didn't have servers and resources and the sort of things you would normally expect to see in a simulation package. So there was still lots of work to be done to make this into a usable open source package. And shortly after we released it, we started working on a new 3D graphic system to replace Java 3D, which was obsolete at that time. And we brought in Matt Shudley, who really wrote an outstanding 3D graphics package for JaamSim, and went on to do all sorts of other great things for the software. But the 3D graphics in JaamSim is particularly good, and it's really thanks to Matt that it's so performant and efficient. But by 2013, we developed the basic objects to go in a process flow library, so the servers and resources and seize and release and those sorts of things, mirroring the sort of functionality you see in Arena or Simio or any of the other traditional software packages. And at that point, we had something that was usable. At this point, JaamSim was actually quite slow. The models we built for our clients weren't very event intensive. We weren't executing a huge number of events. We tended to have complicated code, not so much lots of events. But at that point, we decided we needed to do something about that, and we optimized our discrete event code, really reworked it, and well, by the time Harvey and Matt were finished, we had event code that was significantly faster than everybody else. We were benchmarking the other simulation packages to see how we stood against them, and after 3 or 4 months, we were several times faster than everything else. Unfortunately, at the end of 2015, or by the end of 2015, Harvey, Matt, and myself had all left Ausenco for various reasons. We didn't leave all at the same time. We drifted away one at a time. But unfortunately, that was sort of an end of an era for our simulation department at Ausenco, which carried on in our absence, but didn't thrive quite the way it did prior to that. In 2016, I formed JaamSim Software Inc. to develop the software and to carry on with the development of the software and to really give it all the features that it needed to be a successful and powerful package. And you can see over the next 8 years all the things that were done at various times, and one by one we added all the features that were needed to really make a powerful system. And that brings us to the present time. So, once I was out of Ausenco, I also needed to recreate some of the features of TLS that would be needed. And these are our libraries of objects for material flow, transportation, and maps. And this was a complete clean sheet of paper redesign of this functionality in a way to make it much simpler and easier to learn. Just the So JaamSim Pro was intended for the kinds of mining and oil and gas industry clients that we had at Ausenco, and it was made to be a strict add-on to the open source JaamSim. We didn't, the JaamSim Pro doesn't have a better input editor or something. Everything is exactly the same as it is in the open source. So if you're using the open source software, you don't need the material flow or transportation libraries, then there's no need to license the Pro version. You've got the best one already. JaamSim Pro is priced similar to what the other packages are. It's a little bit less than Arena or AnyLogic or Simio. And the income from JaamSim Pro is what funds the development of the open source JaamSim. So that brings me to the end of my presentation. I hope you've enjoyed it. It's given you some background on JaamSim. I think looking back, I'm pleased that JaamSim did successfully do what we set out to do. That was to make TLS more credible, extend its lifetime, and make it just a much more powerful package. So JaamSim really did do that. Our vision was successful. Now, whether we could have done that at Ausenco and put the huge amount of effort required to do all that is another question. But nevertheless, it was the right idea, the right procedure. But looking back, it's remarkable just how many things had to happen to bring JaamSim into life. First of all, we had to have a motivation for doing it, and that were applications that didn't really lend themselves to the commercial off-the-shelf packages available, Arena or Simio or whatever. Those applications really weren't very suited for those packages, and so that meant that we had to do our own programming. And then we had lots of projects that we were successful enough in doing that. We had lots of projects, and that pushed the development of the software. So it got better and better over years as we did project after project, and we were able to put. It also required the right people to be available at the same time. Harvey and Matt Chudley, Stephen Wong, Jeff Samenkoff are all really crucial to the development of JaamSim, and not to mention the analyst team who were doing the projects, who came up with good ideas to features they wanted in the software and pushed us to do better. And lastly, the desire to create something of value, something of some permanence. Most consultant software, has a finite lifetime. You create it to do projects. It never really gets quite good enough to be worth preserving, and then eventually it dies and never really sees the light of day. In this case, we had something substantial enough that it really made. There was really a strong desire to make this give this a long lifetime, and it's hard to see how anybody else would be able to do something like this now from scratch. If you had to sit down, like I say, there are 30 man years of effort in JaamSim. I don't think you can really realistically do that for an open source project. However, what you could do, if at some point somebody will come along and think that, oh yeah, JaamSim is great, but I really wish they had designed it differently, meaning the objects, the servers, queues, and so on, and has some better idea of what objects it should have. Well, it's quite possible to do that. You could somebody could come along and with a reasonable amount of effort, rip out all our object libraries and replace them with new object libraries that they've designed. And they would still have all the 3D graphics, all the input and output routines, the editors and input builders and so on that we have in JaamSim. Those all work great, but they can have a completely different design for the object libraries. So perhaps that will happen one day in the future. But in the meantime, I think JaamSim is a powerful package, and I'm really pleased to see all of you using it successfully. So thank you very much for joining me today.